This is video 8, where we're trying to solve various types of Fourier analysis problems. The playlist for the videos is at the website at digital-university.org. Okay, in this video, we want to take a look at another sawtooth type function. Here we're saying that f of t equals 3/4 t, and that is when f is between 0 and 8, and it keeps repeating like that. So this would be between 16, 24, and so forth. This would be from -8 to 0, -16 to 8. It's 3/4 t, so the height here is 6. And in this video, we want to find an expression for that in a Fourier expansion, only now we want to use the exponential form. So let's see how we can set this up. First of all, notice that the period for the function is 8. And as we discussed in video number 5, omega is equal to 2 pi divided by the period. So in this case, omega equals pi over 4 in this expression and this expression. So let's first say, well, let's do the simple thing. Let's determine what c sub n is, or maybe even more basic, c0. So n is 0, then we're just going to have 1 over t, and then here this would just be 3/4 of t. So, and this of course is 1 over 8. So what we have is for c0, c sub 0 will equal 1 over t, 1 over 8, and then we'll have times 3/4 t dt, and we can take this then integrating from -0 to 8. Now in these formulas here, it says from minus t over 2 to plus t over 2, or from -4 to +4. It's sort of an entire period of 8. So if we want, we can integrate this from 0 to 8, so long as the length is 8, and we start it and stop it in the right places. So here, we can say this is from 0 to 8. So this will equal 3 over 32, and then we have 1/2 t squared, and t goes from 0 to 8. So this will equal 3 over 64 times a squared of 64 minus 0 equals 3. So c0 equals 3. Now we want to get our expression for c sub n. So let's make some room for that. Now again, c sub n, that's 1 over t, 1 over 8. Our integral goes from 0 to 8, and we have t e to the minus I n omega t. But we just determined that for this problem, omega is pi over 4. So let's put that in there. And this is 3/4 t. Let's take this to the outside. So that is our integral there for Cn. This is just 3 over 32. And again, we have one function times another function, dt here. So we're going to be integrating by parts. So that's dt minus the integral of d du. And then here, hopefully it's obvious, for the u part we choose t, so we'll choose du, we get dt. So u, that u equals t, du equals dt. That means then that dv that equals e to the minus I n pi t divided by 4 dt. So v will equal the minus 4 over this. So that minus 4 over I and pi. And of course it's times e minus I n pi t divided by 4. Okay, so let's see what we have now. We have 3 over 32, and let's just call this integral, save us some space, call that integral I. So we have 3 over 32 times I, or integral I. That will be equal to 3 over 32. Then we have u times v. So here is u, and here is v. So we have 3 over 32 minus, and then we have t right here. Let's write this as minus 4 over I n pi t, and in this part, e to the minus I n pi t over 4. And for the integral I, we are going to t equals 0, t equals 8. And let's just say this. Then we have minus u times minus v du, so minus 3 over 32. The integral of v du. V du is just dt. So we have this now, minus 4 over infinity instead of 8. There. Okay, minus 4 over I n pi. And then we have the integral from 0 to 8, e to the minus I n pi t over 4 dt. Okay, let's see. Let's just look at this part so we can get this thing integrated. So we have minus, minus, that makes this plus. So we have plus 4 goes into 32 8 times. So we have 3 eighths. This. Now this integral, so that will equal 3 eighths, 3 over 8 I n pi, and now for this integral we're going to have minus 4 over I n pi e to the minus I n pi t over 4 going from 0 to 8. Okay, now here we have I squared, that's -1, there's a negative sign, so this, and this go away. 4 goes into 8 2 times, so this part is 3/2, or 3 over 2 n squared pi squared. That's this. So we have 3 over 2 n squared pi squared. Okay. And let's see then. Here we're going to have from this times. Put 8 in for t. So we have 8 divided by 4 is 2. So we have e to the minus I n pi times 2. Put 8 in for the t. 8 divided by 4 is 2. So we have this minus, when t is 0, that's e to the 0 or 1. So minus 1. Okay, now that's what we got from the integral part. Now, this right here should be 1. E to the minus I theta, that equals the cosine of theta. And then we have plus I times minus I times the sine of theta. And the reason is, put minus theta in. For each of the I theta is this plus. Now we have a minus theta. Put minus theta in for here. The cosine is an even function, so that remains unchanged. Put minus theta here, that's an odd function, so we get a minus sign here. Okay. Now here, this is n pi over 2. So for theta, we've got a 2n pi here. So for the cosine, we're going to have cosine 2n pi. That's always 1. This is always 0. Minus I sine 2n pi. That's always 0. This will always be 1. So this is 1 minus 1 is 0. So this whole integral here comes out to be 0. So let's get rid of it, because we're going to need the room. Now remember where this came from. We were saying that our integral I, when we integrate by parts, equals u times v, that's this. U times v, that's this part, minus the integral of v du. That's this part, and this part came out 0. We just showed that. So, this we can get rid of. Now, we can talk about this. So, here we have minus 4, so this will be minus 3/8. I'll just keep it out here. Minus 3/8. Okay, now, so, now 3 over 32 times I, that's 3 over 32 times this integral. That's what Cn is. So, the heck, let's just write in C sub n equals minus 3 over 8in pi. So get rid of this. Okay, times. Now we're going to put t is 8. Again, we have e to the minus I n pi 2. 8 by 4 is 2. Then we have minus when t is 0. F is 0. So this is what we have for C sub n. And let's see. That cancels. And we've just shown that this is equal to 1. So what we end up then with is that C sub n equals minus 3 over I n pi. Or if we wanted to, we could say this C sub n equals, bring the I upstairs, 1 over I equals minus I. So bring the I upstairs, we'll have 3I over n pi. That's our C sub n. So, let's see, we have that determined. Now, let's make some space. Oh yes, and what was, and we don't forget, C sub 0, that was 3. So, those are what we needed to determine. Now, we have f of t, that's the sum from n equal minus infinity to plus infinity, C sub n, e to the I n omega t, but we know what omega is. Omega is pi over 4. There, and we know that C0 equals 3, C sub n equals 3I divided by n times pi. So f of t equals 3 plus the sum n equals pi from minus infinity to plus infinity, n does not equal 0. We take care of that right here. And then we will have 3I over pi, we can take that to the outside of this, plus 3I over pi, we have 1 over n e to the I n pi t over 4. And that is our expression then. So here's how we would express our sawtooth function. Using the exponential form of the Fourier expansion series. Okay, that's it. Hope that wasn't too long. And again, that right there, this is the formula for this sawtooth pattern right here. Okay, come back, join us for the next video, and what we're going to do is consider this type of function. Like a full-wave rectifier. And again, we'll do it both the trigonometric form of the Fourier expansion technique and also examine the same type of problem using the exponential form of the Fourier expansion technique. So come back, join us for those videos. We'll try and solve some more problems.